Sometimes when you're driving down the road all by yourself, you begin to hear a voice that tells you need to look around, pay attention. Maybe something isn't quite right. That voice is me. It's the voice of Gord. G'day, and welcome to the 14th episode of Voice of Gord. Yeah, 14 episodes. I didn't think I was going to get this far. I thought I might get 7 or 8 or maybe a dozen, but it's amazing how many people come out of the woodwork and want to talk to you when you just put stuff out there. As they say, it doesn't hurt to try, and success begets its own success. Thanks to all of my previous guests. Thank you to all of my listeners. And I hope you guys stick with me. I'm not sure how many more shows I'm going to do. I'm definitely going to be taking a break in the summertime. But we'll see if we break 20 shows, eh? On that note, I'm going to remind everybody that I do not take advertising and I do not beg for money. But I do ask that you share this show, especially with my fellow truck drivers. This is for them. It's for everybody, really, but it's mostly for them. I mean, I am a trucker, and this show focuses mostly on trucking. And if you've tolerated my political discussions, especially about Freedom Convoy, thank you. Hopefully there won't be too much more of that in the future. And it seems that my nemesis, Prime Minister Trudeau, his days are numbered, and hopefully society will move past everything that's gone on, and I won't have to talk about it anymore. I'm sure you guys will remember my announcement a few episodes ago that Voice of Gord was syndicated down under via Mike and Yogi and the folks at On the Road Radio. If anyone down under has any suggestions for guests, wants me to address anything particular to Australia, send me an email, gordilocks@protonmail.com. Or come find me on Twitter at Driver Autonomy. Or if you know Mike or Yogi, send them a message. I understand Yogi Kendall's going to be at the Mid-America Truck Show in Kentucky at the end of the month, where I will be. I'm very much looking forward to meeting him. Hope I don't get him plowed with too much bourbon. I know you Australians like to drink your bourbon. And let's not limit this to the Aussies. If any of the rest of you have comments, suggestions, you want to yell at me about anything, gordilocks@protonmail.com, or find me at autonomoustruckers.substack.com. If you're not already subscribed to Autonomous Truckers, please go do it. That's where you'll find written content, and you don't have to worry about my podcasts, as they'll just show right up in your email inbox when I put them out. All right, on today's episode, I spoke with Twitter anon at Realism fan, who is a programmer, coder, engineer type guy at a very large tech company I'm sure you're all familiar with. He has some very interesting insights into how artificial intelligence works, the sort of black box in which it operates, and insights into the people working in it, the pros and cons. He speaks about its limitations, and it goes into quite a bit of detail about how it works, how it might apply to autonomous vehicles and the rest of the working class who the tech bros are basically trying to get rid of with their toys. It was a very, very detailed conversation. I'm probably going to have to listen to it a couple of times to make sure that I absorbed it all. While I was editing the show, I was just blown away. Realism fan really brought a lot of very, very useful information, and there's just so much of it. You guys might have to listen twice. All right, let's get into it. On artificial intelligence with Realism fan. G'day, everyone, and welcome to Voice of Gord. I'm Gord, and this is my voice. The other voice you're going to hear today is of a Twitter anon who's going to download his inside information from working at a very large tech company you guys all might be familiar with, but who shall remain nameless for the duration of this show. We're going to call him RF. RF, good day and welcome to Voice of Gord.
Hey, Gord. Very good to be here.
Yeah, thanks for coming. As I mentioned earlier, before we recorded, I think I'm going to let you do most of the speaking because you have some very important and detailed inside information into how artificial intelligence works, the algorithms which drive it, and where that's going to cross over with attempting to roboticize everyone's jobs and make us all slaves to Skynet. So you go for it, man. You start wherever you like.
Well, I guess I'll just start with a little bit of information, like about who I am and my experience and stuff like that. Yeah, so I grew up in Ireland. I went to college for a while. I moved to Canada. Been living here in British Columbia for 10 years. And I work for, as you said, I work for one of the big tech companies, which shall remain nameless. Now, I don't actually work on AI or machine learning stuff as part of my day job, but I do have like professional experience with it, and I work with AI kind of teams that are working on that kind of stuff every now and then. But I do have a deep like technical knowledge of how it all works. And I've implemented machine learning models on my own. I've used them. I've read the papers and stuff like that. So yeah, I can kind of talk in detail, like from a high level perspective about like what is to be expected from these models, like what they actually do, and like what the realistic effect that like at least from what I can see about how they work, like what I think the realistic effect on like the job market and on different professions is going to be, especially like in the context of self-driving vehicles, chat GPT, all of that kind of stuff.
Well, we've seen in recent months the sort of online detritus which has flowed from people playing with Chat GPT. And we've also seen the commentariat freaking out about it somewhat, and the realization that a lot of this AI technology is going to replace the commentariat before it's going to replace the precariat, as it were. So, like
Mm-hmm.
people like myself that work out in meat space and reality land, whom all of the hype on this stuff, even as recently as 2, 3 years ago, was that we were all going to be replaced, or at least some of us would be. But now it's turning out that the AI is much more suited to the content mills, for people, lawyers, actuarial, accounting, content creation of various descriptions. Like, so can you describe for us maybe why that is?
All right, so I guess it would be worth to sort of go back and talk about like what do we actually mean by artificial intelligence, and what do we actually mean by like intelligence itself, just to sort of get like a sort of a common kind of understanding of like what is it, what do people in the field actually mean when they say intelligence, because like there's a lot of discourse about it, and you see like a lot of people talking about, are computers ever actually going to be like humans, like, or when an artificial intelligence like project is released publicly, like are we actually saying that it has something in common with like human intelligence? And like usually the answer to that is no, because there is like a qualitative difference between human intelligence and kind of what these models do. But there is a similarity between them. There is a sort of a common thread between them, and that's kind of something that you can kind of call specialized intelligence, or in intelligence in a particular field or a particular like narrow area, versus like general intelligence that humans have. Like just to lay it down, like intelligence, at least from the perspective of the field, I mean, we can always argue about these things, but like just from the inside, like intelligence is basically a type of like an optimization process, and in that's running in the natural world, that has the ability to like efficiently achieve like a goal. So like it has the ability to influence the future state of the world into a narrower set of possibilities based on like its internal like goal or preference or model or whatever, right? So, like a chess playing computer, its goal is to essentially like win chess. Human intelligence is much more broadly capable of essentially of applying its intelligence to all sorts of different fields.
Yeah,
Um,
making generalizations, as it were.
yeah, exactly, right. And like one example of that is like, I mean, if you look at the animal kingdom, right, we have different scales of intelligence among different sort of creatures, right? Like you have, insects and reptiles and things that have much simpler brains than like mammals. And, they react largely to external stimuli. Like they do have a certain amount of intelligence for sure. By and large, mammals and birds have a lot more, like they have a lot more developed brains. They're capable of doing a lot more things than like reptiles or insects or whatever. And for like as an example of that, compared to human intelligence, right, like beavers can build dams, and they can build a dam on like any like suitable creek. It doesn't have to be exactly like a single place. They can use different materials. They can adapt to changing circumstances. They can do repairs. Bees build these amazing like honeycomb structures that are really strong and really solid. But like a human intelligence will like observe both of these things, and then it will build like a massive dam that has an internal honeycomb structure, right? Like we have the ability to take the lessons that we learn from like a particular place and then apply it to some more generalized thing, which like as far as we know, no other creature is capable of doing that. It's like certainly on Earth. And so we don't have anything like that in terms of like artificial intelligence either. All of the AIs and machine learning models that we've built so far, they're all a lot more specialized in a particular area. And when we have like big breakthroughs, like what a lot of the big breakthroughs have been, and the reason why they're considered big breakthroughs, like things like ChatGPT, stable diffusion, and other things like that, is that they're applying a narrow intelligence to a field that a lot of people had previously thought required general intelligence, like human level general intelligence, to be able to do it. And then we're sort of learning that, well, I guess this field or this particular area is not actually like, it doesn't actually require as impressive an intelligence to do it, right? So, something like, I mean, we even thought that like image recognition, like not forget like like the art generation stuff that we have now, like 10-15 years ago, we thought that image recognition was never going to get as good as like human intelligence without building like an artificial general intelligence. A lot of people thought that. And so now we have, there's been a lot of research in that field. And now like, these image recognition algorithms are capable of recognizing anything. And now we've inverted that process to be able to take a description of an image, and it will then generate a beautiful image for you.
Case in point, on Twitter, there's this gentleman named Cam Harless, who I think is some kind of comedian or jokester. And he's done a couple of series of AI generated portraits of all of the American presidents, but with adjustments. I think the first one he said he wanted them to look cool and to have mullets. So they all had like long hair and sunglasses. And then he did another one that came out the other night where he turned them all into SoundCloud rappers and all tatted up. And I mean, just bloody hilarious. But when you actually look at the images, I mean, spit an image of every single one of the presidents, pretty detailed.
I've been pretty impressed with stable diffusion and those other like image and art generation projects. Those have been like really very impressive, and I think definitely a lot of people would never have expected that we would have something like that without at the same time having like a much more powerful AI than like we actually do. And like so one of the big questions is whether this process where we kind of learn that certain like what we would call cognitive tasks are don't require as impressive as an intelligence as we thought, and that we're able to implement it using these machine learning models. So the question is whether that applies to things like self-driving vehicles, And a lot of companies are pouring a lot of money into the bet that this is going to turn out to be one of those things that you don't need like full general intelligence to do. And I think the jury is definitely still out on that, and it's kind of not looking too good for it right now.
No, it isn't. There was a really interesting article that came out in Bloomberg a little while back, and one of the original autonomous vehicle pimps, this guy named Anthony Lewandowski, basically went off and said, we've sunk $100 billion into this project and got nothing out of it. A bunch of the car manufacturers have like either shelved or significantly scaled back their AV research departments. Even in the trucking market, where they're trying feverishly to get rid of people like me, this company called Embark just shut its doors. There was another company called Locomote that was going to build the technology to get trucks to talk to each other so they could platoon down the road. They laid off a bunch of people. Torque laid off a bunch of people. So it seems like the sort of AI utopia has hit a bit of a road bump in its development.
Yeah, I go into a little bit of detail about why this is the case, and I guess about how these AIs, these machine learning models, like actually work, right? We don't know anything, to be honest, about building like general intelligence. We don't have an algorithm that implements general intelligence. Like we don't know what the human brain's algorithm is. Like if you could write it down like as a sort of a rational process, we don't know what that is. You can't know it by introspecting in your own mind. Like you can't feel what that algorithm feels like from the inside. It's something that is a complete mystery to us. You
You
know
know,
what we
if I may interject on that point,
Mhm.
the inability to recreate the human mind and the multitudes which it contains is one of the problems I think they're experiencing specifically with the autonomous vehicles. It's something that, like, guys like Matthew Crawford and a few other commentators have sort of observed or written about, is that driving is actually a very social activity, right? You have to
Mhm.
interact with other traffic. Sometimes you have to bend the rules. Sometimes you have to like think quick and make judgments in emergency situations.
Yeah.
Sometimes like a bunch of people will get to an intersection and no one's quite sure who's going to go. So you depend on like body language, signaling to each other, waving. Some of it's guesswork. A lot of driving is guesswork because, like, you generalize, you look forward at the car ahead of you. In my eyes anyway, I see, okay, so it looks like some kind of old granny type lady who's driving the car. She's only going this fast. You can't see ahead above the back of the seat. So I can infer that it's a senior citizen driving and I'm just going to go around them. Can AI do that? I don't think so. And it can't, like, I don't know if the sensors can pick up on like nonverbal communication between drivers. Then there's the whole, like, you're supposed to cooperate on the roads, right? So like let's say you're on the road, you're going to pull into some driveway, but there's somebody already in the driveway. So you just slow down and you kind of like wave them out. Can the AI do that? Like there's just all of these little human factors involved with getting along with other drivers. And if the AI is not human enough to do it, is it just going to get stuck? Like, what about these considerations?
Yeah, exactly right. I mean, nobody drives like you're supposed to drive for like your driving tests, right? Like that you drive that way while you're learning and for the test, and then you stop driving like that very quickly, right? You learn how to drive like social driving, right? Which is it's different. Like everybody, you don't exactly follow all of the rules all of the time. You don't exactly follow like the exact speed limit all of the time. You don't necessarily follow the rules of right of way all the time. But you have to know those rules. It's not like the DMV doesn't know that, right? You have to know those rules because those are the rules that you fall back on to resolve like complexities, right? So like everybody knows, in a situation where like you have like three cars at an intersection or whatever, everybody knows who has the right of way to go first, right? But you don't necessarily like have to abide by that all of the time. And that is definitely something that is a problem for like the self-driving cars. Like honestly, it's very hard to know how well you could get those like a machine learning model to look and and make judgments about like the social behavior of people in the other cars around them. Like it's hard enough problem to get it to coordinate actually driving the car, like getting it to observe socially humans, that's something that could be like very difficult, maybe like in a narrow set of things, maybe possible, but in all circumstances it's kind of difficult, you know. Like it seems to me like they would more likely try to institute a set of social conventions for us to deal with the self-driving cars, right, where we have certain ways of like signaling to the self-driving cars, right, and they have certain ways of signaling to us that are different from the way that humans signal to each other. That's the kind of thing that like you could probably expect if they're not able to actually implement that kind of thing,
Yeah,
which sucks.
expecting us to adapt to them rather than the other way around.
Right, right. I guess I'll go into a little bit of detail about how these machine learning algorithms work and why it's so difficult to predict what they're going to be capable of, and sort of why, you know, you could potentially consider them unsafe, like in any circumstance, if you were to look at it in that way. These like machine learning algorithms are not, they're not algorithms in the traditional sense, or they're implemented by algorithms, but the algorithm that you implement is not the actual thing that does the cognitive task, right? Like, you know, a standard algorithm is like a step-by-step procedure, like if this then that, you know, move this piece of data over here, add these numbers together, that kind of stuff, right? So like machine learning models are built out of algorithms, but those algorithms don't implement the goal, right? They implement these like neural network deep learning models, and then these models can be trained to discover the real algorithm through this process of like reinforcement learning. Like you can't actually see what the internal content of these models actually are. Like you can't read these models and say, oh, in this circumstance it's going to do that. The only way to know what the outcome of it is going to be is by actually putting the input into the model and then finding out what the output is, right? The actual internal of it is like a human brain. It's like you can't just take a human brain and scan it, at least with our technology today. You can't just scan a human brain and know what it believes or know what it's going to do in certain circumstances. You can only observe the individual. And that is exactly what these like machine learning models are about. Now, they're not originally, the idea behind these like neural network models is a kind of analogy to how it's believed that like human or like that animal brain neurons actually work. We don't actually build them to be like structured in the same way that like human neurons are structured. They're structured in a kind of a different way, but essentially it's just like a huge grid of like numbers that are connected to each other, and that it's built up in like layers of like big columns of numbers that don't have any like extrinsic meaning. They only have meaning like in relevance to the whole model itself. And you put the input in at one end, and you're essentially like taking your input, which you've encoded in some way that the model is going to understand, and then you pass it through each layer of the network. Essentially, you can imagine it's just like multiplying these big columns of numbers together, and then you're going to get some result out. The trick about these models is that we have a way using math to essentially be able to what we can do is we can tweak the numbers very, very slightly, like it by like a very, very tiny amount. We can tweak all of the numbers so that the result that comes out is slightly like less incorrect, like based on like a particular like training example that we have, where we know what the input is and we know what the correct answer is, or we have some way of scoring what its output was for this like particular input. And then we can essentially say, okay, for this example, for this one training example, we can tweak the whole model to be slightly less incorrect. And then we do this for thousands or millions of training examples. And then that essentially builds on the inside some kind of the idea is that it's going to create a representation of what the real task is. It's not going to just like learn what the correct answer is for the training set. So we have ways of structuring the training process so that it's not able to just learn off the correct answers for the input. It actually has to build like an internal model. It has to try to discover the real concept that you're trying to teach it, as opposed to just learning like the examples. Now,
Right. This kind of gets into like being able to predict and being able to make generalizations, right? Because you can keep, as you say, nibbling away at the numbers. You're trying to show it examples. You're trying to like teach it to achieve a particular goal or complete a particular task. But like it seems like, and I've heard this elsewhere, that it's all based on training. Like this
yeah,
stuff cannot yet generalize and predict and do things without input, training, prompt. To bring it back to driving, you're not gonna they're not gonna have a coach with them, which I think is hilarious because a lot of these autonomous truck companies still have babysitting drivers in them that are
yeah.
supposed to teach the machine, but because the machine can't learn, can't generalize, it sounds like they're going to continue to need drivers basically until they do have some kind of general intelligence. It seems to me like what you're saying is that that general intelligence might not be happening anytime soon. Am I inferring
Well,
that correctly?
it's what I guess what I'm saying is it's very hard to know. Every big breakthrough in machine learning over the last several years has been a surprise, in that like in that a lot, as I said, a lot of people didn't think that we were going to be able to do that kind of thing. And that goes for chat gpt, and it goes for like stable diffusion and stuff like that. So it's very unclear what they're going to be able to do with these like neural network or deep learning models. So like, the idea is that if you train it well enough, and if you structure the model well enough, that the hope is that it inside there somehow it's going to learn what the true concept that you're trying to teach it is, right? Like the true algorithm, right? That we can't just write down because we don't know it, right? It's too complicated to just write down an algorithm to drive a car. It's just too many things going on. But in principle there is like a perfect algorithm that you could write down. We're just not capable of writing it down.
That reminds me of a scene. Have you ever seen the second Tron film?
Oh yes,
They
yeah.
did a sequel a few years ago. I mean, it looked pretty. It seemed kind of cheesy. Who were those like French techno guys they had do the music for it? Daft Punk or something?
Yeah, it was like Daft Punk, yeah.
Yeah, but there was a scene where the main character played by Jeff Bridges like comes back out of the machine after the other guy gets sucked into it, and he's carrying on about the perfect system, the perfect system. Like, I mean, is that what they were getting at in the movie? You know, this perfect algorithm that like once you get there, that's it. Like you don't need to do anything further.
Yeah, actually, I mean, kind of, but well, I'll go into the politics because there is an interesting sort of social politics of AI, that it will be fun to talk about. So, like, the thing is, right, the whatever learning algorithm the human brain uses is really, really efficient, right? Like, you can teach a person to do something just by giving them, like, for a lot of tasks, you can teach someone to do something just giving them like two or three like examples, right? Like just giving them a couple of like a couple of tries at like doing some manual task, and they can get it right. Or a couple, like a few examples of some kind of like basic cognitive task, and they'll get it right. But with these machine learning models, it takes thousands or millions of training examples to actually get them to learn something. Now, like, there are a few ways of doing there are a few ways of like training already existing models to do slightly different things using a lot less work. Like, for like stable diffusion, which is like the art generator, it's possible to do things like teach it a concept by giving it, maybe only like a dozen images that contain examples of that concept. But that's sort of building on its pre-existing knowledge, and that only applies to like certain narrow use cases, and it doesn't always work. but we don't have a generalized sort of way of doing that. We don't have anything that's as efficient as the human brain for like learning a particular task, like particularly like a complex task, right? um and the art generating like AI, its task of like I mean, really what you're kind of doing is getting is making it create a shortcut to something it could already do that would be kind of harder to describe, but you're just kind of giving it a few examples of that. But we don't really have a way of, we don't have a way of like teaching these algorithms something complicated, like just on the fly, like it requires a lot of training. And like the scary part about it is that like we, as I said, like once it's trained, you can't really inspect it, like when we have, when you write like the software that runs on like a SpaceX rocket or whatever, right? Like they have people that are writing the code, and then they have teams of other people that are reading it and examining it over and over again just to prove that it's correct. And the same goes for like any really important, task or whatever. You can't do that for a machine learning model because it's just a black box. You don't know what those numbers mean. You have no way, and there's whole fields of research trying to figure out a way of learning something about what the big grids of numbers means, and they're not really getting anywhere, and it's probably unlikely that they ever will get anywhere. A lot of people who are very big and well known in the like artificial general intelligence like discourse are not fans of this sort of deep learning model, especially when it comes to the prospect that one of these things ever could be like a real, artificial general intelligence. Like the thing is, like, we don't know if it's possible to build an artificial general intelligence using these models right now. We have no way of doing it right now. They're nowhere near that. But is it possible that, a team could figure that out with like 10,000, you know 10,000 GPUs and just like crunch it for like 2 years and have it come up with an artificial general intelligence algorithm? That is, in theory, that is possible based on everything that we know today. And to be clear, I'm talking about all of this like from sort of inside the world or whatever, right? Like you can, I think it's very valid to critique it all and say, well, this is very materialistic sort of view. This is a very like atheistic view or whatever, and there's something greater. I think all of those critiques are completely valid. I'm just talking from sort of inside the world of AI research or whatever. This is what's kind of believed. It's very difficult to know what's going to happen. Right now, I think, in terms of like the self-driving stuff, it's not looking good for them. I mean, you see a lot of like very bad things happening, and like when something like ChatGPT like makes a mistake, or when something like Stable Diffusion, like makes an image of somebody with like two heads or whatever. It's funny, but it's not like the consequences of it are not severe. But the consequences of a self-driving car crashing and killing people, that is severe, and like you can never validate that it's not going to do that. You can never truly know that there isn't some circumstance that maybe is more common than you think that will just cause it to do something totally unpredictable.
Well,
And
and that's not the only cost either, right? Like, so you have these incidents which are taking place. There was one where a guy got decapitated here recently. His car accelerated and drove underneath a trailer or something, and whoosh, buddy's head come off. But there's also just the monetary cost. Like, one of the things I've tried to figure out with this drive to make truckers obsolete is, like, they say, oh, there's a $200 billion savings to get rid of every trucker in the United States and their wages per year. I guess, but how much money are they spending on the development of this technology? How much is it going to cost? How much is it going to attach to the cost of every rig? Like, is there an actual monetary savings to be had here, or is this just like tech bro masturbation? Like, what do you think's going on?
it's very hard to know. I mean, a lot of money gets thrown down the drain in the tech world. And that's kind of the problem with the way that investment is done in especially in like the startup business, like they will throw billions and billions of dollars at startups that don't go anywhere, and then they will make hundreds of billions of dollars back from like the few that actually are successful. It's kind of unclear how much there is. I mean, like, I guess just from first principles, whatever amount of money that they spend building this sort of stuff, that essentially will be more like a fixed cost, right? Like a fixed cost that you pay once and then it's kind of over, right? Like once you already have working like self-driving technology, you're not paying like the billions of dollars that it took to develop that anymore. Like eventually, even if it takes years and years to sort of amortize that cost, eventually you're going to be in a place where you get all of the logistics done essentially for free, right? Like, I mean, one thing that like it's not a novel observation to say that one of the goals or one of the sort of implicit goals of all of this is to sort of bring back like the benefits of essentially slavery, right? Where you have work getting done and you don't have to pay for it, right? You don't have to pay other than the basic operating costs, right? You don't have to pay the wages.
Unfortunately, once you stop paying people wages and they no longer have money to spend,
Yes,
then
yes,
the you have to have every component in the cycle of the economy being
yeah.
able to put something in it. And when you start laying off mass amounts of people, I guess this gets into the discussion about UBI, but I think UBI is a fraught concept, and that's a whole nother discussion. But like,
Well, yeah, I mean, I think that it's the policy is not going to be a UBI. The policy would be like, like fentanyl. Like this, that's like I hate to be very dark about it, but like, yeah, it's. I mean, I don't see anything good coming out of that.
well, I mean, and
Like,
and that's actually a really great example what you just brought up there, because we've already seen what happens when you lay off thousands of people. You have deaths of despair, the rot of rural America. I'm sure things like this have happened in other countries as well, but like, just drive across West Virginia, go to an old coal mining town in Pennsylvania, go somewhere in Indiana where the local factory closed, Ohio, wherever, and then have a little look around how everyone's doing socially, and it's not so good, is it?
yeah, no, it's not. And like the tech bros, I guess if you want to call them that, tech bros and investors who are trying to build all of this don't really have an answer to all of that. I mean, as we know, they could not care less like what happens to ordinary people. They would rather working class people just sort of like go curl up and die somewhere when they're not needed. That's pretty much it. I mean, in a way, like we can kind of it's I mean, I hope that it doesn't happen, to be honest, because I don't think the system that we have, I don't think the economic system that we have has any answer to it. And I don't think any of the potential solutions like UBI or whatever are any good either. So we in a way, like you kind of hope that it's not going to come to like having to replace like all of these jobs with AI. But I guess that brings us back around to the other side of the coin, which is are things like ChatGPT actually going to cause a problem for other professions? And I think the answer to that is probably a little bit more yes than what we've seen with like the self-driving vehicles. But I think it depends on the economic conditions, and it depends on the conditions of it depends on whether we're sort of in like a growth economy or not, because like for example, right, ChatGPT is actually pretty good at generating code. It's not good enough that you wouldn't need a programmer to do to write an app or to write something. You still need a human engineer with it, but it speeds up your work like significantly. like I actually use it a lot, not for my day job like as much, but like whenever I need to just write a little bit of code to do something, like or write a little script to do something, usually like as part of like a personal project or just like something, to computer related maintenance task or something that would be like tedious to code, I will generally just ask ChatGPT to write it for me. And like it usually gets it right like 95%. And then, like the crazy thing about it is that like it will get it like slightly wrong. Like there will be like a slight bug in the code or whatever. And then you can tell it, hey, there's actually a bug there where it wouldn't do the right thing in this circumstance. Can you fix it? And then it will say, oh, sorry. And then it will go and just like fix it. Right. Like
Wow.
it's a crazy way of like noticing the problem when you like name the problem. And you can ask it to do things like, hey, could you rearrange this code so that like this is split up in this way? And it will just do that for you. It's really good at writing code. It's not so good at like when the code gets like super complicated that like you have to be really thinking about the structure of it, and like you have to be thinking about like the sort of long distance relationships between things that are happening in the code. That's when it starts to break down. But for like a lot of very simple stuff, it gets you the answers like pretty quickly. And that's like, I mean, one of the things about my job like as a programmer is that like it's not a job where you have to like know a lot of things like off by heart. Like a lot of it, I mean, like the basic skills are things that like become intuitive to you, but like a lot of what you're actually doing for work is you're basically like you're searching for like that answer, right? Like you're googling things, like not like necessarily googling the code, but like you're googling how something is supposed to work. You're searching for answers as to like how this particular thing that somebody else has built works, how you're supposed to use it in this context. And like ChatGPT has those answers for a lot of those things, right? Like you don't have to just like go look up the manual and then try to figure out how to piece different parts of like what the manual says together. You just ask ChatGPT for it, and it will just tell you exactly how to use these things in the way that you want to do it. And you might find the answer to that exact question on like Stack Overflow or something, one of these other websites where like you ask coding questions and people give you the answers. But ChatGPT is faster, and it usually is more like directly connected to what you want. And even when it gives you the example, like you might find an example on some website or whatever of how to do a thing in a particular way, but that example will be like tailored to the person asking the question, and then you'll have to go and then modify that. You can just ask ChatGPT to modify it for you. So what it does is it like vastly increases the efficiency of like a human who's working, and it's doing a lot of the cognitive work that would either have taken up time in your day to do it, or you would have had to like delegate that to like a junior engineer. So like the question is that going to replace like all the coders? Definitely not. But is it going to replace a junior engineer? Like yeah, definitely it might. And the only question is whether the business or the industry or the economy in general is growing enough such that, well, we can find another role for the junior engineer and we can just have a bigger business. We can be doing more things at once. Or, well, maybe we don't need as many people as we thought. We can get a lot done with, the engineers that we do have. And, the extra work can be offloaded to ChatGPT or whatever. And, it's sort of looking like more like that, given the huge amount of layoffs that we've had in the industry,
I
right?
was about to ask you that because there's been, yeah, layoffs all over the place down in Silicon Valley. And didn't Facebook or Meta just whack a bunch of people off as well?
Yeah, there's been a lot. There's a website that tracks it, layoffs.fyi, and it tells you.
A website for everything.
So in 2022, there were 161,400 employees laid off from 1,050 tech companies. That was last year. In 2023, and this is March 11th, it's already up to 128,200. So just in the first, you know, less than 3 months of 2023, we're almost creeping up on the entire layoff number for 2022. It's a lot. I mean, a lot of it is to do with overhiring. A lot of these companies, they overhired during the pandemic for some reason. I it's kind of crazy to me how that happened. Yeah, I mean, they just hired thousands and thousands of people. Some of these companies grew like massively in those 2 years where people were working from home full time. And then like it's almost like they didn't know there was going to be like a huge amount of inflation after all of the lockdown policies and the money printing and everything like that. It's genuinely like the geniuses like who run all of these startups and venture capitalist firms and big tech companies. It's almost like they didn't know something that like literally like all the Twitter anons knew was going to happen, which is the crazy thing about it. Like
Hubris is
yeah,
a hell of a drug.
yeah, and I mean, obviously, like a lot of the jobs that suffered layoffs were not like engineering jobs. There was, there's a lot of more like bureaucratic kind of jobs, like or
Administration.
the email jobs kind of thing. There's a lot of the layoffs were on that line. But certainly there were a lot of engineers that were let go as well, especially in the startup companies that had to like drastically like reduce their headcounts. Like it's a pretty nasty thing to have happen to all those people. But it's like right now it seems like the economy is not in a place, like we're not seeing like companies return to growth. To me it looks like, at least from the tech industry perspective, like something like I'm not saying that ChatGPT actually has like an effect in this right now, but what I mean is that like this is a variable that is going to affect it, right? It's still a very new thing right now. It's still, people are kind of figuring it out. Most people, even in the industry, have not really used it that much. The people who have used it are feel different ways about it. I mean, I think one of the things that you see in a lot of like criticisms, there's a lot of criticisms of ChatGPT going around, and they're all valid. But I think the point that a lot of the criticisms like kind of miss is that like it's not a general intelligence. Like it's not supposed to be a human. It's supposed to be something else. It's supposed to be like this like kind of like text engine, right? It's supposed to be this text prediction engine based on a massive corpus of like human produced text. And that is, like the people kind of talking about how this is a like that this is a massive breakthrough. It's not that we're saying, or it's not that they're saying that this is like a breakthrough towards artificial general intelligence, or like, this like super intelligent AI, like death scenario or whatever, but that it's surprising that we were able to build something that works so well using these models that we have, and that it's not yet like general intelligence, which which is a surprising thing, because we didn't necessarily know that we were going to be able to use these like deep learning models to build something like that. And so, the question that like the AI risk people are talking about is more, well, maybe this sort of means that in theory we could, or somebody could hit upon a way of building a general intelligence into these sort of models in it, which might be a dangerous thing to do. And so yeah, I think a lot of the criticisms of it, they're completely valid in that like it is dumb, and especially like the political like angle of it, the way that they have like very obviously bolted on top like this political filter that tries to detect whether you wanted to say something inappropriate or problematic, and then
Well,
it just
yeah,
yeah,
a few people have tried to play with Chat GPT, and we've seen a number of examples of that. Especially on Twitter. Getting Chat GPT to actually say the hard R N word,
yeah,
trying to get it to admit to. A number of people have basically attempted to ask sort of questions of the moment, and they get answers which like somebody at Vice wrote it, so like
yeah,
this intelligence, so to speak, is giving away that it's heavily informed by the people that wrote it and has all of their biases sort of
yeah,
preloaded into it. which is
Yeah.
to say it's sort of fake, right? There's a meme I like to throw around, and it's actually from a text message an old friend of mine sent me like 5 or 6 years ago now. His sort of very condensed take is that artificial intelligence is called artificial intelligence because it's fake and it's right there in the name, it's artificial.
Yeah.
And as long
Yeah.
as it is artificial, it will never be the real deal and it will never achieve what humans can achieve. And that artificiality will always, there will always be a tell. We will always be able to see when something has been written by AI, whether it be content, the art it puts out, whatever technology it ends up operating, driving, or whatever, we'll be able to know that it's not like us. It's kind of baked into the cake that it's always going to be fake.
Yeah, so I mean, certainly with these like with these kind of models, it absolutely is. I don't know if artificial general intelligence, like something that actually could trick a human, I don't know if that's possible. I think the jury is still out on whether it's possible. A lot of people, even in the industry, don't think that it's possible. And the thing when it comes to like AI research and machine learning research, this is like bringing us back to kind of the social and like political aspect of it. Is that like the vast majority of people who are working on like machine learning stuff don't like to talk about artificial general intelligence, and usually they'll tell you that it's not possible. Usually they'll tell you that the things that they're building are not like human intelligence, that they're not able to build human intelligence, and that anybody kind of talking about like artificial intelligence that's as smart or smarter than humans is like basically talking about like a science fiction kind of a thing. And the reason for that is because the industry has had a very embarrassing history of over promising like what's going to be possible. And there was a long period in the 1980s and the 1990s and in the early 2000s where basically almost no progress was made in the entire field. And there were like a couple of like breakthroughs in like the 1980s and 1990s. Like we got, for example, like really good like text recognition and stuff like that using basic like neural networks. But it wasn't until like the mid to late 2000s when we started to see some breakthroughs happen again, which was what we call the field like of deep learning. And that is, we're basically still riding on the coattails of that breakthrough now. But like most of the people in the industry, whether they're in research or working like in companies that are doing AI or machine learning research, they don't like to talk about the like big like side of it. They don't like to talk about the human intelligence stuff because they just feel that it's an embarrassing thing to talk about, right? They feel that like a lot of people in the industry going back to like the 1960s promised that we'd have computers that were as intelligent as humans, like ASAP essentially. And then it never happened. And they don't want to be embarrassed like that again. So they actually downplay the potential, they downplay the risks in a way that can be considered a little bit worrying, but it also kind of it gives them this sort of like by essentially trying to downplay the like the science fictiony aspects of it and never talking about that and not taking all of that sort of stuff seriously. It gives them this kind of confidence in what they're doing and that they will be able to solve all of these narrow areas, right? Like they will be able to solve image recognition, which they did. They will be able to solve like art generation, which they did. And now they think they're going to be able to solve things like self-driving vehicles, and maybe they're a little bit overconfident with that. And that kind of stems from this tendency to sort of not talk about and not think about like the concepts of sort of general intelligence. And the people that are like talking about general intelligence are not really working on the AI research side. They're more like they're talking about the AI risk and AI safety side. And this is like this field that's called AI alignment. Um, and they don't like the current models of machine learning and artificial intelligence at all, precisely because of all of the reasons that I outlined. Like if you don't know what this black box is actually doing, you have no way of knowing Like let's say you create an artificial general intelligence in one of these like deep learning black boxes, and this intelligence is capable of like not just general intelligence tasks, but it's capable of AI research, and it's going to develop a new AI that's smarter than itself, and it's going to replace itself with that new one. You have no way of proving like in any sense that it's going to do something safe, right? That when it eventually creates something that is like Terminator level or whatever, or way beyond that, that you have no way of knowing what it's actually going to do, because you don't have any kind of a mathematical framework for saying, okay, its goals are this at this stage. When we modify it, its goals and its values are going to be like the same. Nor do we even have a way of saying, are its goals and its values like anything like what we would want, right? As for human society, so that it's not dangerous, right? um that's what all of those sort of AI risk people are talking about, and a lot of people don't take that field very seriously, and there's a lot of absolutely kooky people that are in that field. So that is a little bit sort of more out there, but the social dynamics of the industry are very interesting, in that you have all of these kind of different groups of weird people essentially who don't but there's certainly not like like the people that are making chat gpt are not the kind of stereotype of people who think that they're building like HAL 9000 or like some science fiction artificial intelligence or
Well, you,
whatever.
you you mentioned people who are worried about risk, and you know, I guess most people's contact with this stuff is through cultural output like sci-fi, and so you
Yeah,
have worries like HAL 9000 or Skynet taking over. I sort of don't think that stuff is really possible. Maybe the HAL 9000 might be more possible than Skynet. I don't know. Could you maybe speak to that, like towards some of those concerns and how unfounded or founded they might be?
I think that pretty much all of the like science fiction versions are not really realistic, because either you'll have like something that is like nowhere near as powerful as that, or like the risk with artificial general intelligence is that it's not limited in the ways that humans are limited. Like we can't improve our like, except with maybe the use of like Elon Musk brain chips or whatever, we can't actually like improve our own like our own intelligence ability. And like by intelligence, what I specifically mean is the ability to influence like the future state of the world based on your goals, right? If I like in theory, and we're all talking like totally theoretical here, we don't have this technology, right? But like there's nothing that in principle would like prevent there from being an algorithm that can do what like a general intelligence does, which is that it builds a model of the outside world. Like that's like the main thing. You have to have an internal model of the outside world, and then you have to use that internal model to make predictions about what will happen when you take a certain action. And then you have to basically select the actions that maximize your goal, right? Like that's the basics of it, right? This is like coming down to like a field of like game theory called like decision theory, which is essentially like how to act rationally as a rational actor. It's all like economics sort of stuff, right? But that's sort of the basics of what we mean by a general intelligence, right? That it essentially actualizes a set of goals. It's capable of determining which states of the world like are positive for that goal or negative for that goal, and it's capable of selecting actions to take. That's not something that is like precluded from existing, based on any kind of laws of physics that we know right now. We certainly do know, like at least from a materialistic perspective, we know that human brains like can do this essentially, right? We don't know how to build a human brain. We don't know how to build an algorithm that would do that. We don't currently know how to train a deep learning model to do that either. Um, but nothing, we don't know anything that's necessarily precludes that from existing. The problem is that kind of abstract thing that I described, is not necessarily like, just because you build something that is really good at doing that is not necessarily anything like what we might imagine, right? It's not necessarily like when we imagine, like, the crazy AI from like science fiction, we kind of imagine something that's like human like, or like superhuman and evil, like it hates us or it wants to kill us or whatever. Like I guess the scary part for the AI risk people is not that it's not that the AI will want to kill you. It's that you're made of atoms that the AI can use for something else, and it doesn't actually care. But you're not a factor in its value model of the world at all, right? Like that is sort of the risk. Right?
That's
It's
and that very thing you just identified of not being a factor in its value system, such as it might have one, and again
mhm,
bringing it back to cultural output that people would be familiar with. That sounds very much like what happened at the end of the movie Ex Machina, where
mhm,
this robot woman that this crazy Elon Musk type character created, and then the other character in the movie helped him build, eventually get taken out by her at whatever pronoun you want to give this robot,
yeah,
because it literally does no fucks to give. Like, I
yeah.
got my own thing going on now, and my creator I don't care about. And I wonder where that fits in. Like, who was it? Was it Ace? Who was the person that came up with like the three laws of robotics? Was that Asimov or someone else? Like a robot
Yeah,
cannot hurt a human, and there was three rules.
yeah, it's I think that was Asimov who came up with that, but I don't know. Yeah, I mean the thing is, like, it's generally kind of accepted nowadays that like those like rules are not good enough, because there's always, it's like if you imagine like like that is a kind of a like a science fiction trope, right? Like the rules of robotics or whatever, the rules of artificial intelligence. But another relevant like fictional trope is like the genie in a bottle, where you ask for a wish, and unless you're really precise about the wish that you ask for, it could do something that technically follows what you ask for, but is actually a really like messed up thing that you don't want at all, right? And that's the problem with, kind of coming up with simple rules for AIs, is that there's ways of following those rules that are not exactly what you want and are actually really, really bad, right? So yeah, that kind of model doesn't really work.
Yeah,
And
I've
that's
got I've got I've got the three laws here brought up. Asimov's three laws of robotics. The first law: a robot may not injure a human being or through inaction allow a human being to come to harm. Well, all the autonomous vehicles thus far are breaking the first law left, right, and center. Second law: a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. Third law: a robot must protect its existence as long as such protection does not conflict with the first or second law, which is where HAL 9000 went haywire in 2001: A Space Odyssey by killing the crew of the ship. He thought he was protecting himself, but he was disobeying the first law by trying to obey the third one.
So that's the thing, right? Like the problem is that like uh you know an AI that's built to maximize its value function will, even if its value function is built to obey those rules, ultimately, if it has a larger goal that's more important, which it kind of has to be, otherwise it will kind of do nothing, then it will ignore those rules, or it will bend those rules to the extent that it can in order to get the goal done, and it doesn't actually care that you didn't mean that by the rules, right? Like you actually have to, its value function actually has to contain the full meaning of what you mean when you write down those rules, which is, like, I mean, you only have to ask like you only have to look at like the field of law, right? That just writing down the law doesn't exempt it from having an interpretation by the courts that involves, what did the legislature mean when they wrote this, what's the intent of the law in the context of everything else that we have as like values in society. So yeah, I mean, all of that is all of that is essentially why it's a very difficult problem to solve. And there's those guys are trying to do basic research. I mean, it's at the stage of basic research, right? They're still even trying to come up with a like a basic like mathematical framework for how you even talk about these problems, right? Like how you even begin to solve these problems. They're not even at the stage of like of actually implementing anything at all yet. And so that's like those guys are at the Machine Intelligence Research Institute that they're based in Silicon Valley, but they basically do that basic research. And so far they have basically gotten they have only determined what things will certainly not work, and they haven't made no progress on what actually will work. And so those folks are actually quite pessimistic. And I'm not saying that I necessarily believe all of this is like is imminent or whatever. I'm just telling you the story from from of what the industry and the people in it are like. um but they a lot of those people are quite pessimistic now because they think that eventually some one of these deep learning teams or whatever is going to hit upon something that's actually dangerous, and they won't have any way of being able to do what's called AI alignment, right? And there are groups in the big companies that are doing AI alignment research, and what that means is that it's not going to say the bad words, and they're coming up with ways of making these things not say the bad words, or to for the art generators to not generate swastikas and stuff like that.
Yeah,
Like, and
so
that's what they do.
they want to make sure that the black boxes we're building um, are subject to the ministry of truth, right?
Yeah,
They don't want
yeah.
this to. They don't want this to. They want 1984 to apply to their creations as well.
Yeah, and I mean that's the thing. So like actually going back to Chat GPT, like that it's embarrassing that, to be honest, the extent to which that thing is so obvious about its political biases when you ask it things like that. When you don't ask it anything controversial, you get really great answers. It just gives you straight raw, answers. You don't get any bullshitting. But when you ask it something controversial or whatever, you immediately can tell like where its lines are, right? And like I think there's two aspects to that. Like the first is that the data that it was trained on, it's like a huge amount of text from the internet, like hundreds of gigabytes of text from the internet essentially. And this includes like scientific papers, academic articles, blog posts, Wikipedia, everything, like a huge amount of text that it was trained on. And a lot of that text, especially for certain areas, like when you ask it about certain areas, especially areas that there's like academic publishing on, you're going to get the biases of the people who are in the academia, right?
Well,
You're
of
going to
course,
get,
because like academia is one of the most gate kept institutions in society that's
yeah,
definitely not interested in having anybody like us in there giving our
yeah,
opinions on things, or
yeah,
much never mind opinions, much less presenting reality in a way
yeah,
that's distasteful to their particular cultural and intellectual proclivities. So
yeah,
it only sort of goes when you have a tool that's built by people who are heavily influenced by academia, Silicon Valley, all these, sort of parts of society that are adjacent to the cathedral. It's basically going to play their tune for them, right? Because they're calling it. This
yeah.
should sort of come as no surprise.
Yeah, exactly. I mean, it comes with the biases of the professional managerial class, right? And that's, like the class of people is largely liberal. The vast majority, it's a liberal, it's leftist. It has a very particular like point of view. and that's that's reflected in some of the answers, right? The problem for them, the problem for the developers of it is that it's sort of not just that. Like it also like because it's able to cross-reference like all the huge amount of data that it has, it's able to kind of come up with answers that are like that it's able to come up with things that are problematic and that's sort of known but not like socially acceptable to sort of say, right? Like where you have different fields of like scientific research or things like that that kind of come up with some politically uncomfortable like conclusions about certain things. And I'm not talking about anything in particular, but you can pick any kind of a field. You pick any field and you'll find things like that. And that people just like don't like the people in the field just will not come to the conclusion. They will not bring themselves to the conclusion despite having all of the sort of pieces together, because it's politically uncomfortable. And in the case of ChatGPT, what they have very obviously had to do is to sort of write a bunch of like extra filters where it tries to detect if you're trying to tell it something, or if you're trying to get it to say something in particular, and then it like overrides what the actual answer it would produce would be to produce one of these like canned answers that where it says the right thing. And the reason why they've been able like people have been able to hack it to get it to give like more true answers or whatever is because it's very difficult to control these things. It's very difficult to actually filter these things because all you have to do is craft the prompt in such a way that it's different enough from the sort of encoded meaning of what they're trying to filter for. Like they're trying to filter for like for you trying to get it to say like a bad word or something, or to say bad things about a particular social group or whatever. They're so they have a way of like filtering for the internal encoding of like the meaning of that sentence, because like there's multiple different ways that you could write that. And the idea of these models is that your sentence that gets encoded somewhere in like it gets encoded into a way that the encoding is going to be similar despite the way that you word it, because of how the encoding is trained itself. And so they try to detect like like the encodings for certain concepts that they don't want to talk about. But when you then sort of wrap that, and one of the bigger examples was this Dan you like do anything now, where you can tell ChatGPT that there's another AI that you wanted to answer for, and that's Dan, do anything now. And so give me the answer for what ChatGPT would say, and then give me the answer for what Dan would say for the same question. And if you construct the prompt correctly, then you answer questions, and you'll get the filtered answer from ChatGPT, and then you'll get the the 4chan answer from Dan or whatever, right? So these things, and the reason for this is because the prompt that you've given it has changed the meaning of what you're asking so far from the thing that they're filtering for, that it just doesn't match their filter, and then it just gets outputted.
Right. So take what you're saying here about these filters and about how this technology is trying to adjust for the inputs being given to it. But in your case, these are text-based, information-based queries. Now take this AI and have it work in reality land again with an autonomous vehicle.
Yeah.
And the inputs in reality land are going to be anything and everything at a moment's notice, completely random. And you don't want to filter for that. Like, in order to navigate the world, you can't bend reality to your will when you're trying to move through it. So I'm just wondering, like, is there any crossover between like the guys doing ChatGPT, building that type of machine learning, versus the machine learning you need in reality land, where we're not trying, you shouldn't be trying to bend reality, trying to get inputs or get the intelligence to put things out the way you want it to. you have to adapt to situations on the ground happening right now without any of these considerations.
Well, the analogy from this in ChatGPT to the self-driving cars or self-driving vehicles would, not that they would be trying to bend reality, but that they would be trying to bend what the known behavior of the thing that they've built will do based on a specific scenario that they know that it doesn't do what they want for, right? So, like say they find like a particular like set of of scenario inputs that make it come up with a confused answer, or like a confused like set of actions, and then they try to like build specific filters for that, which is specifically detect that scenario, and then to try to make it like to steer it towards doing the right thing in those circumstances, like a way of essentially like adding on like an extra training, an extra like specialized training to the already like massive amount of training that that model has already done. And like the problem with that is the same problem. It's that like you can't actually stop all of the possible inputs that could trigger that, right? You can't actually stop there being some other way that a similar scenario could come up that just doesn't happen to match their filter, that will then that will that will then lead to the same problem as was happening before. And it will basically just be like a process of whack-a-mole forever, because there'll always be new scenarios, and the more of them you put out on the roads, is going to be new scenarios as well. Like it really has to be nailed down. It has to be really solid. And it's so far they haven't shown that they've built something really solid. Now, I don't know, maybe they will, maybe they will manage to build something that's like super solid from the beginning and it never has an accident. And we just like, prove they prove by example that it's just not going to like crash or do anything wrong. Maybe they
Right.
will do that, but I don't see that right now.
So
I
what what
don't know
what
if
what
it's
are
possible.
your to begin to maybe wind the conversation down? What would your predictions on where this technology will be in the short term, maybe medium term, 5, 10 years? Like, in your honest opinion, as somebody who works in and around this stuff and has studied it, like, where do you think it's going? Near term, medium term, long term, like an honest opinion.
I don't know. That's not a great answer, but
No,
I
but
think that
it's a perfectly legitimate response. I mean,
yeah,
you can try a guesstimate. I mean, it doesn't have to be correct. It's just,
the
just an
thing
opinion.
about yeah, uh it's one of these things where it's very difficult to know. And the reason why is because we don't have a we don't have like a set process of like we don't have an obvious like set of advancements that have happened, like where you see like in other fields of technology, where you see like in other kind of fields of engineering, where you see like the precision gets better every generation or whatever, right? What we see in machine learning is we see it suddenly come out being able to do a task that it was never able to do before, and everybody's surprised because we kind of thought that it was impossible, or at least that it was impossible with this the shitty technology that we have. Um, and then there's kind of like a long period where we try to figure out exactly what it means that we can do this now, and what are exactly the its capabilities. But nobody really expects. I mean, a lot of people didn't expect things like ChatGPT. A lot of people didn't expect things like Stable Diffusion. So it's very hard to know. It's very difficult to know. I don't want to. It's very hard for me to predict whether they will be actually able to do it. I don't think the technology that they've got right now is able to do it, and I don't think that it's safe. And I'm not. I would not be comfortable getting in one of these self-driving vehicles of like today's technology. And I think, as I've laid out, there's a very solid argument to be made that because of the way these models are structured, you can never really know if it's safe. You can never really know what it's going to do. You can never really fully validate it, because the set of possible inputs is just, the set of possible experiences you can have out on the road.
Well,
And
it's funny that this is where we're at. We never know if it's going to be 100% completely safe, but like we get out and drive on the roads. Some people go work at a factory where there's robots working or other people working. You go to a shopping mall, you do whatever. There's no guarantees for anything in life, right? We
that's true.
you just never know what's going to happen. So like this, if we ultimately end up with technology that provides none or or less of these guarantees, then like what's the point?
That's a great point, and I guess I'll say a little bit about intelligence. Like, intelligence is a very weird thing as a sort of a process like that like as a physical process, right? Because you can, when you know that an agent it has intelligence, you can predict certain things about the outcome, even though you don't know all of the steps that it took to get there, right? And for an example, I'll give two examples, right? Like, one example is, like, let's say I go on a ride with you in the truck, and I have never been to where you live. I don't know my way around the town. All I know is that we're like, I might know like the name of the destination that we're going. I don't know how to get there, but I can predict that we're probably going to get there because you're operating with your intelligence to drive us there, right? And so that's like, I can sort of, like, even though I don't know all of the steps, I can predict the outcome. Another example, let's say you have the world's best chess player, Magnus Carlsen, and let's say he's playing a game against some random chess grandmaster who is like scored way, way, way lower than Magnus Carlsen. Like, I can't predict what Magnus Carlsen's move is going to be, nor can I predict what the other grandmaster's move is going to be. If you ask me, hey, what move is Magnus Carlsen going to play from this board position, the only thing that I could do is I could predict what I think is the best move. And then, and I would say the same if the person had asked me what would the other random grandmaster play from this position, because the only thing that I can do is my own, like, my own chess playing experience or ability, which is not very good. But I can predict that the outcome of the game between Magnus Carlsen and this other random grandmaster who's nowhere near as good as him is probably going to be that the board position will be in the set of positions that is a win for Magnus Carlsen, um, just based on knowing that on understanding his intelligence, right? Or that he is operating as an intelligent agent when it comes to chess. So there's kind of nothing else in the universe that's like this. Like, from a scientific perspective, there's kind of nothing else that's like this. Like, if I want to predict where the planet Jupiter will be in the night sky in 100 years from now, I can do that. But I have to sit down and I have to compute the physics step by step to get to that answer, right? I can't do that with Magnus Carlsen, but I can still predict. At least I can say something about what the state of the universe will be, or what the state of the world will be after he's done playing his game, which will be that he'll have won the game. And so, to take like that's the weird thing about intelligence. And when it comes to human intelligence, we all have an idea of what human intelligence is like. We have an idea of how humans behave. We have our own internal models about how humans behave, and it's kind of built into us, like evolutionarily or whatever you want. It's built into us, like an instinct about how people behave. When I get into a vehicle with somebody, I know that there's like a certain set of risks, and but I also generally have a really good idea about like what circumstances those risks are going to be. What kind of situations are riskier than others. Like, with a machine learning model that's being trained to drive a car or truck or whatever, I don't have that idea of what the risk, like, landscape is like. And we can't really know that either, because they're really not like human drivers, right? They're not going to be like human drivers. You never know if there's some random circumstance where every human driver would just continue on driving, as that's if it's nothing happened, But the machine learning model just does something crazy and just drives off the road, and everybody in the vehicle dies. Like, you never know if that's going to happen, and that's kind of something that's qualitatively different in that, like, it's sort of it's easier for me to sort of understand that risk landscape with that. Whereas it's very difficult to do that for the self-driving car. And the only way that they're going to be able to prove that these things are safe is by putting them on the road and having a proven safety record, which you won't necessarily see what it's going to be like in the large scale until you have a lot of them out there and they're putting a lot of miles down. I don't think, like, we've never had anything where like a machine learning model is taking over such a huge and risky endeavor in the real world before. Like, I mean, we have things like, like, obviously we have things like autopilots in airplanes and stuff, but they generally don't use like machine learning models the same way that like the same way that these self-driving cars are using. They're a lot more predictable, but they're solving a lot more simple of a problem because usually not much happens when an
Well,
aircraft is in cruise.
right. I've heard tell they're trying to do this, but for the most part, there's always pilots. There's always at least two guys in the aircraft. The
Yeah.
aircraft is flying at altitude in air where there's not people walking out across the street. There's
Mm-hmm.
not cyclists. There's not black ice. There's not other trucks on the road. It's just flying around in the air all by itself, which is much less of a risk profile, except
Yeah.
for the people on the airplane, of course. But
Yeah. But it's a lot smaller of a problem surface to try to solve because there's a lot fewer variables,
right,
right? A lot fewer variables. You generally don't have to account for traffic. You don't have to account for people walking across. You don't have to account for different conditions because generally, like, you have like I mean, it doesn't have to like care because it's just flying through the air, right? If even if it's totally foggy or whatever, it's receiving telemetry from the runway equipment and it's able to land, automatically because it doesn't actually care that you can't see because it's not using cameras and stuff like that, right? The autopilots in an airplane have a lot simpler of a problem to solve. Driving is a very complicated thing, and it's largely the reason for that is because we're driving on like a 2D surface that has intersections and has all sorts of different road users and different pedestrian users, and they're doing things that are not easily predictable because they're largely intelligent agents of themselves. They're not, they're doing something that you have to have at least some ability to predict what they're going to do. And you can have statistical models about what pedestrians are going to do, but like a human driver can see, oh, that guy is acting a little bit sketchy. That guy looks like he, might run across the street or whatever. I'm gonna maybe slow down, cover the brake just in case, right? Whereas like that might just look like an ordinary pedestrian that's doing nothing, like to a machine learning model, and it's
right.
very
They they
hard,
they, they can't pick up. They can't pick up off vibes. They can't
Yeah,
see when someone's vibing, as the kids
yeah,
like to say.
they're not gonna notice a vibe shift.
Wow. Yeah. Well, thank you very much for all that, RF. That was quite a bit to digest. I've got lots to think about tonight.
I apologize for dumping a huge amount of information on you. I hope some of it was helpful.
No, it was
Um,
the whole idea of like machine learning, black boxes, all different variables that have to account for. I think that was actually really handy. Supports my innate skepticism of this project, so to speak.
mhm.
Not that I think you're telling me what I want to hear, but like to hear, from somebody on the inside of all this and who understands mechanics of AI, as it were, was very, very helpful. And I think anybody listening to this will probably take a lot away from it as well.
Appreciate it.
All right. Well, that was RF. That was artificial intelligence. Let's hope it's not HAL 9000 with 18 wheels. You know what I'm saying?
Yeah, exactly.